Good morning, Namaskar. So, welcome back in this subject. In the last lecture of this subject, we have to discuss one topic that is generally asked in the examination, and that is phase diagram, alloys and phase diagram. Alloys and phase diagram. It is a theoretical topic. There are several alloys. Some of them are iron based alloys, they are known as ferrous alloys. Some of them are other metals alloy, copper, nickel, zinc, etc. So they are known as non-ferrous alloy. So each and individual alloy is not possible to discuss in the class because of the time limitations and other factors. So those has been written in 2 chapters in your theory book. You can refer that, the properties and applications of individual alloys. But here in this chapter I am wanting to discuss the basic concept behind the alloy formation, how the alloys are formed and what are the key concepts which are involved during the formation of an alloy. Individual alloys property and their applications. For that purpose you need to refer the theory book. There are 2 chapters, one named as ferrous alloy and the other named as non-ferrous alloy, right. So let us go for first heading in this chapter. The first heading is alloy and compound. When we mix 2 elements, let us suppose we are mixing hydrogen and oxygen. So if they are mixed in appropriate proportion, they will make H2O. H2, these are different elements. One element is hydrogen, other is oxygen, and this is a compound. This is a compound. But when we mix carbon and iron, it makes steel and it is an alloy. You have to keep in mind that when H2O is made, hydrogen and oxygen are bonding with each other and they have geometrical configuration like this. This bond angle is 104.8 degree. So they are bonding with each other to make the compound. Light चली गई. रमेश इज आस्किंग कि सर मटेरियल साइंस की क्लास हुई थी डबल ई के लिए, क्या पेपर 2 के लिए? नहीं बेटा, आज 1 बजे से है your second class. The class for the electrical engineering materials and electronics materials is scheduled from 1 o'clock. पिछले 2 दिन वो क्लास कैंसिल हुई. उसका रीज़न ये था, पहले से क्लास प्लान्ड थी, बट आपको पता होगा कि इंजीनियरिंग सर्विसेज का रिज़ल्ट अनाउंस हुआ है 22 का. तो उसमें मुझे जो बच्चे सेलेक्ट होते हैं उनके साथ टॉपर स्टॉक करके एक मेडी जी की सीरीज़ आती है यूट्यूब पर. जो बच्चे सेलेक्ट होते हैं उनके साथ उनकी जर्नी के बारे में डिस्कशन. एक तरह से उस सीरीज़ का उद्देश्य ये होता है कि उन्होंने किस तरह की स्ट्रैटेजी अपनाई ये आप तक पहुंचाया जाए, जो लोग प्रिपेयर कर रहे हैं उन तक पहुंचाया जाए. तो मुझे टॉपर स्टॉक करना होता है तो ईसी और इलेक्ट्रिकल बैकग्राउंड के बच्चों के साथ में. तो 2 दिन मैं उसमें बिजी था. इस वजह से दोपहर से लेकर के एंड रात 8-9 बजे तक की सारी क्लासेस कैंसिल थी एंड वी वर रिकॉर्डिंग द टॉपर स्टॉक. बट मोर और लेस मैंने रिकॉर्ड कर लिया है और अब जो वो यूट्यूब पर रिलीज़ भी हो चुका है. सो अब आज से सारी क्लासेस रिज्यूम हो रही हैं. थोड़ा सा मेरी क्लासेस में टाइमिंग का रहता है इशू, बिकॉज आई हैव टू गेट इन्वॉल्व इन सेवरल थिंग्स. तमाम सारी चीज़ों में इन्वॉल्व रहते हैं तो थोड़ा सा मैनेजमेंट इधर उधर होता रहता है समय का. होप यू विल मैनेज इट. चलिए आइए देखते हैं. तो यहाँ हाइड्रोजन और ऑक्सीजन के बीच में बॉन्डिंग हो रही. हाइड्रोजन एंड ऑक्सीजन आर बॉन्डिंग विद ईच अदर, देन कंपाउंड इज फॉर्म्ड. बट अगर आप इसमें देखें, सो दीज आर द कार्बन आयरन एटम्स एंड between 4 iron atoms there is a small interstitial position. Carbon atom is occupying that interstitial position. So there is no bond formation. when these two elements are mixed, there is no bond formation. So key point which differentiates alloy and compound is कि when two elements are mixed, then if a chemical bond is formed, then a compound would be formed. There are several examples of compound like NaCl. Here Na and Cl are mixed, they make a ionic bond, so a compound is formed. But if two elements are mixed and they do not form a chemical bond, then an alloy is formed. अब कुछ point because of this, if bond is formed, then the geometrical arrangement of compound is totally different than the arrangement of atoms या elements. जिन एलिमेंट्स को मिला करके कंपाउंड बन रहा है, तो क्योंकि कंपाउंड एक नए तरह की बॉन्डिंग लेकर के आ रहा है, सो इट्स ज्योमेट्रिकल अरेंजमेंट वुड बी टोटली डिफरेंट देन द एलिमेंट्स जिनसे ये बना हुआ है. बट हियर यू सी, सिंस देयर इज नो बॉन्ड फॉर्मेशन, सो जो स्टील होगा, दैट स्टील विल ट्राई टू रिटेन द क्रिस्टल स्ट्रक्चर ऑफ होस्ट मटीरियल. होस्ट मटीरियल मतलब जो मटीरियल लार्जर इन क्वांटिटी है, सो उसका क्रिस्टल स्ट्रक्चर रिटेन होने की कोशिश होगा. फॉर एग्जांपल, इफ आयरन इज बीसीसी, सो स्टील विल हैव बीसीसी क्रिस्टल स्ट्रक्चर विद सर्टेन डिफेक्ट. Those defects are interstitial defects. So carbon is only producing defect, but it is not changing the crystal structure. So it will try to retain the crystal structure of the host material, जिसे हम लोग solvent कहेंगे, solvent का crystal structure, जबकि यहाँ पर ऐसा कुछ भी नहीं है, totally new crystal structure बनेगा. Compound can have totally different physical properties than the constituent elements. For example, H2 is a gas, O2 is a gas, but here H2O is a liquid. So the properties of H2O are totally different as comparison to the constituent elements. But if you talk about steel, then the properties of the steel are intermediate between the carbon and iron. So they will try to retain the properties of the constituent elements. एक और चीज, अगर हमें एलॉय में कंपोनेंट्स को सेपरेट करना है, वी वांट टू सेपरेट कार्बन एंड आयरन, जस्ट मेल्ट इट. On melting, carbon and iron can be separated. So components in alloy can be separated by melting. But अगर हमें H2O में components को separate करना, compound में components को separate करना है, तो melting is not the right way, because when you melt it NaCl, still it will be NaCl in the molten state. So you cannot separate sodium and chlorine. Yeah, if you heat H2O, it will become H2O vapor, but hydrogen and oxygen cannot be separated. So to separate elements in the compound, we need to perform chemical reaction, whereas to separate elements in the alloy, just we need to melt it and then they can be separated. In the alloy, percentage component of the constituent elements can be varied. You can add 0.1% carbon, 0.2% carbon, 0.3, 0.4, 0.5, like that. So percentage component can be varied, but in compound, percentage component is fixed. Atomic weight percentage is fixed, that cannot be varied. So these are certain differences between alloy and compound. You should be knowing these differences. So एक line लिखते हैं, then एक table बना करके उसमें हम इनको compare कर देंगे, या एक टेबल में ही डायरेक्टली कंपेयर कर लेते हैं. एक टेबल बनाते हैं एंड इन दैट टेबल, लेट अस सपोज वी मेक अ टेबल एंड वी पुट 2 कॉलम्स. मैं लिखूंगा नहीं, मैं डिक्टेट करूंगा, यू हैव टू राइट इट. फर्स्ट कॉलम इज एलॉय एंड सेकेंड कॉलम इज कंपाउंड, एंड वन बाय वन वी कीप ऑन डिस्कसिंग कि what are the differences. Thank you Ritvik. उद्देश्य भी यही था कि आपको कुछ आइडिया मिले और जो यंग एस्पिरेंट्स हैं उन्हें कुछ आइडिया मिले, बल्कि जो टॉपर्स हैं वो भी सारे मेरे स्टूडेंट ही हैं, तो उन पे मेरा हक है कि उनको, तो मैं उनको इंटरव्यू शुरू होने से पहले ये चीज़ बोलता भी हूँ कि कुछ भी बहुत ज़्यादा भौकाली मत बताना, वही बताना जो प्रैक्टिकल है, जो तुमने एक्चुअली किया होगा. ऐसा नहीं कि अब टॉप कर गए हो तो कुछ भी बोलने लगो. समटाइम्स होता है कि लड़का टॉप करके आता है तो बोलता है मैं 18 घंटे पढ़ता था, विच इज़ नॉट प्रैक्टिकली पॉसिबल. सो all these students are very grounded and they are great achievers. So they try to tell only those things which they have followed during their preparation. और मेरी कोशिश भी थी कि छोटी छोटी बातें जो कई बार रह जाए, जैसे मुझे एक बड़ा अच्छा पॉइंट एक गैल कैंडिडेट ने नोटिस कराया कि सर जब हम रिवाइज करते हैं, वी कीप ऑन रिवाइजिंग द सेम थिंग सेम अगेन एंड अगेन सेम थिंग, सो उससे क्वालिटी एडिशन नहीं होता. सो व्हाइल सॉल्विंग प्रॉब्लम व्हेन सी वाज स्टक इन सम पर्टिकुलर प्रॉब्लम, सो उस पर उसने नोटेशन कर लिया था कि अगर ज़्यादा डिफिकल्ट लग रही तो उसने डी लिख दिया, और भी ज़्यादा डिफिकल्ट है कि सी इज़ फॉरगेटिंग द कंसेप्ट अगेन एंड अगेन, तो उस पर उसने डबल डी मार्क कर दिया. कोई चीज़ थ्योरेटिकल है व्हिच सी थॉट दैट इट नीड टू बी मेमोराइज्ड, तो उसने आर मार्क कर दिया. सो देन सी सेड दैट कि मैं सप्ताह में एक बार जो ये मार्क्ड पार्ट होता था हर सब्जेक्ट का आर डी डबल डी, तो उसको जरूर रिवाइज कर लेती थी. तो अगेन एंड अगेन रिवीजन के बाद उसको वो चीज़ें कंफर्टेबल फील होने लगी. सिमिलरली वन स्टूडेंट टोल्ड कि सी यूज टू मेक शॉर्ट नोट्स, सो सी हैज़ मेड 10 to 15 pages of short notes of every subject. So now she is having a 15 small notebooks in which one subject is summarized. So that's also great. She said that when I go for any other examination other than the GATE and engineering services, so need not to revise the whole syllabus, whole textbook. Instead I take only those 15 small notebooks of 10 to 12 pages and revise them. So different has different strategy. Like one boy asked a question to me कि सर ये पूछिएगा कि दिल्ली में अभी ठंड बहुत ज़्यादा हो रही है, सो इस ठंड में आलस बहुत ज़्यादा लगती है, नींद बहुत ज़्यादा लगती है, सो हाउ टू ओवरकम दिस. तो उसके लिए भी जो स्टूडेंट थे उन्होंने भी सेम सिचुएशन फेस की. सो दे केम अप विद द आइडिया कि सर जहाँ इतना खर्चा हो गया एक रूम हीटर रख ही लेना चाहिए, इट विल हार्डली इंक्रीज द एक्सपेंसेस बाय 2 to 3,000 1 month or 2 month. सो दैट्स नॉट दैट मच ग्रेट इशू कि 2 महीने बर्बाद कर दिए जाए. सो small things, but those were the important, so I tried to incorporate those questions. Right. ये पहला टॉपिक है दृष्टि मौर्य हैज आस्क्ड कि व्हाट इज द फर्स्ट. दिस इज द फर्स्ट टॉपिक. ये तो मैंने समझाने के लिए किया है, ये लिखने की जरूरत नहीं है. यू नीड टू राइट फ्रॉम हियर. सो स्टार्ट राइटिंग. फर्स्ट पॉइंट इन एलॉय लिखिए. When two or more elements are mixed, here you write please. When two or more elements are mixed, more elements are mixed, when two or more elements are mixed and they do not form a chemical bond, and they do not form a chemical bond, when two or more elements are mixed and they do not form chemical bond, then it is termed as alloy. Then it is termed as alloy. Then it is termed as alloy. Compound में लिखेंगे. Now please write in compound. When two or more elements are, compound में लिखेंगे. When two or more elements are bound together, two or more elements are bound together, bound together, bound together by chemical bond, by chemical bond, then it is termed as compound. Then it is termed as compound. Then it is termed as compound. Next point. Next point. नेक्स्ट पॉइंट एलॉय में लिखेंगे. देयर इज नो केमिकल फार्मूला फॉर एन एलॉय. देयर इज नो केमिकल फार्मूला फॉर एन एलॉय. There is a chemical formula for an alloy. There is no chemical formula for an alloy. There is no chemical formula for an alloy. कंपाउंड में लिखेंगे देयर एग्जिस्ट अ केमिकल फार्मूला फॉर अ कंपाउंड. There exists a chemical formula for a compound. There exists a chemical formula for a compound. Full stop. Next point. In alloys, weight percentage of components can be varied. Third point. In alloys, weight percentage of components can be varied. Weight percentage of components can be varied. कंपाउंड में लिखेंगे इन कंपाउंड वेट परसेंटेज ऑफ कंपोनेंट्स इज फिक्स्ड. Weight percentage of components is fixed. In compound, weight percentage of components is fixed. Next point. Alloy में लिखेंगे an alloy has physical properties which are intermediate between those are constituent elements. Those are constituent elements. Full stop. कंपाउंड में लिखेंगे compound can have different properties. Compound can have different properties. Compound can have different properties. Than those of constituent elements. Constituent elements. Next point. alloy में लिखेंगे components of an alloy can be separated by Components of an alloy can be separated by melting, can be separated by melting. Can be separated by melting. Compound में लिखेंगे the individual components of compound the individual components of a compound can be separated through chemical reactions, can be separated through chemical reaction. Chemical reaction. Chemical reaction. Full stop. Next point. Alloy can be considered, alloy में लिखिए, alloy can be considered, alloy can be considered alloy can be considered as a solid solution, as a solid solution which tries to retain which tries to retain the crystal structure of host material, which tries to retain the crystal structure of host material. होस्ट मटेरियल. कंपाउंड में लिखेंगे केमिकल कंपाउंड have a unique and definite chemical compound have a unique and definite crystal structure defined by its chemical bond. Defined by its chemical bond. So, this was difference between alloy and compound. Dear, compound we have already studied. Ceramic compounds are the examples and several other compounds we have studied. Polymers, they are also compounds. Here we have to study alloy. So, in this chapter we are more focused to the alloy. Alloy can be known as solid solution. Solution is when we are mixing two things, that is known as solution. So, since it is in solid state, so it can be said as solid solution. So, let us put heading solid solution. Solid solution या alloy. We have two important terms. First term is solvent. It is the host material. It is the material in which other material is mixed. So it's larger in quantity. Larger in quantity. So the material which is larger in quantity, that will be known as solvent. The other term is solute. So it is lesser in quantity. Lesser in quantity. So in fact, solute will dissolve into solvent to make a solution. Please keep in mind, alloy will be formed only if there is no chemical bonding. It means there is no new structure. So we can add that much solute until the crystal structure is not changing. If the crystal structure will change, then it will not remain the alloy. Defects may be formed, but if the solvent is BCC, then overall structure should be looking like BCC with certain defect. Solvent is FCC, so overall structure should be looking like FCC. So we can add only that amount of solute till the structure remain intact. या solution tries to hold the crystal structure of solvent. So इस बात को लिख लेते हैं. So please note down. Sir, is an alloy said to be formed only when two or more elements are mixed? Can an alloy be formed by mixing two compounds also, or if one is compound and other is element? Dear, when you are mixing any compound with the compound, ultimately the mixing would be taking place at the atomic level. If the mixing is taking place at the atomic level, then it is alloy. If it is not taking place at the atomic level, let us suppose you mix one compound with the another compound. Suppose concrete की बात कर लें हम लोग, घर बनते हुए देखा होगा. So sand is one compound and cement is another compound. We are mixing them. That's not an alloy. That is basically a composite material. So when interaction between two materials does not take place at the atomic or molecular level, it takes place at the larger scale, then it cannot be said as alloy. For the alloy, the interaction should be taking place at the atomic level. So whenever you are mixing two compounds, probably atomic level interaction is not possible until you increase the temperature. So if you increase the temperature and components get separated and mixing takes place at the atomic level, then alloy may be formed. But if the mixing is not taking at the atomic level, then it is not an alloy, right? So please go ahead. लिखें जरा. A solid solution forms. A solid solution forms. A solid solution forms when the solute atoms are added. The solute atoms are added to the solvent. And crystal structure is maintained. And crystal structure is maintained. That is, no new crystal structures are formed. That is, no new crystal structures are formed. No new crystal structures are formed. No new crystal structures are formed. Full stop. The amount of solute that may be dissolved by the solvent, increases with increase in temperature. Increases with increase in temperature. The amount of solute that may be dissolved by the solvent increases with increase in temperature. Increases with increase in temperature. There are two types of solid solution. There are two types of solid solution. Substitutional solid solution and interstitial solid solution. Interstitial solid solution. There are two types of solid solution: substitutional solid solution and interstitial solid solution. Please note down quickly. I said, Ansu, I said a solid solution is formed when solute atoms are added to the solvent. Solute atoms are added to the solvent and the crystal structure is maintained. That is, no new crystal structures are formed. No new crystal structures are formed. आइए वन बाई वन इनको देखते हैं. फर्स्ट वन, substitutional solid solution. Substitutional solid solution. If you recall, in crystallography I taught you substitutional defect. What happens? A foreign atom comes and it replaces the parent atom. So let us suppose it is the copper crystal structure. Let us suppose these are the copper atoms. So this is the copper crystal structure and you add few nickel atoms. These all are copper atoms. Copper atoms. It is larger in quantity, so I say it as solvent. Now suppose you add some nickel atoms. Some nickel atoms suppose you add. So you add some nickel atoms. So nickel atoms will replace copper and take their position. So the crystal structure is more or less which was having with the copper. So the crystal structure is retained and these are the nickel atoms. So such kind of alloy where the solute atoms are replacing the solvent atom, but the crystal structure of solvent is maintained, that is known as substitutional alloy. Alright. So लिख लेते हैं इस बात को. If the size of solute atom is similar, क्योंकि इस केस में साइज ऑलमोस्ट सेम होना जरूरी है तभी रिप्लेस कर पाएंगे. सो यू कैन राइट इफ द साइज ऑफ solute atom is similar, if the size of solute atom is similar to that of solvent atom, to that of solvent atom, then solute atoms can replace solvent atoms. Then solute atoms can replace solvent atoms to form substitutional solid solution. To form substitutional solid solution. The solubility of solute atoms, how much solute atoms can be dissolved, that is decided by a rule that is known as Home-Rothery rule. So, the solubility of solute atoms into the solvent can be decided on the basis of Hume-Rothery rules. So, next heading is Hume-Rothery rules. Hume-Rothery rules for formation of substitutional solid solution. Hume-Rothery rules for formation of substitutional solid solution. There are 4 points. First point is atomic size factor. लाइट चली गई थी. सो नाउ आई मे बी विजुअल टू यू. किसी ने पूछा है कि सर इट इज अ काइंड ऑफ डिफेक्ट. यस, व्हेनेवर वन मटेरियल इज एडेड इनटू द अदर मटेरियल देन इट विल फॉर्म अ डिफेक्ट. सो इट इज सब्स्टिट्यूशनल डिफेक्ट. Atomic size factor. The size of both of the elements should be almost same. There should not be difference in more than 15%. Then only this kind of solution can be formed. The atomic radius of two elements, the atomic radius of two elements, the atomic radius of two elements should be same, should be almost same. That is, the difference in atomic radius should not be greater than, should not be more than, should not be more than plus minus 15%. Should not be more than plus minus 15%. This is the atomic size factor. Second, crystal structure. Both the constituent elements should be same crystal structure. Like copper is FCC, nickel is also FCC. Then solubility would be greater. If both are having different crystal structure, then solubility would be lesser. So both elements, yeah, for appreciable solid solubility, crystal structure for appreciable solid solubility, both elements should have same crystal structure. Both elements should have same crystal structure. For appreciable solid solubility, both elements should have same crystal structure. Third, electronegativity. Both of them should have same electronegativity. Yeah, electronegativity difference should be minimum. Because if electronegativity difference is more, then the elements which is having higher electronegativity will try to snatch the electron. So bond formation के chances हो सकते हैं. But to make an alloy there should not be any bond. It means they should have same electronegativity so that bond formation is avoided. So the solute and solvent atoms should have same electronegativity. Yes, similar electronegativity. The solute and solvent atoms should have similar electronegativity. Fourth one. Fourth is valencies. Suppose you replace copper. So copper has two valency. So new atoms which is substituting the copper, if that is having same valency, then overall crystal structure will remain neutral. So in order to sustain the structure, neutrality must be maintained. Hence both of the elements should have same electronegativity ताकि जितना निकल करके गया है उतना बैलेंस किया जा सके. So both solute and solvent atoms should have same electronegativity, same valencies. These are the 4 points which are crucial in determining the formation of solid solution, substitutional solid solution. So for appreciable solid solution, the size for appreciable solid solution these criteria should be followed. सुनंदा क्या मजाक क्वेश्चन पूछा आपने. प्लस माइनस 15% लिख दिया तो कोई भी एक दूसरे से 15% से बड़ा या छोटा नहीं होना चाहिए. So either you talk about solvent or you talk about solute, both should not be greater or lesser than each other by the 15%. Their difference should not be greater than 15%. So चाहे x1 minus x2 करो या x2 minus x1 करो, it should not be differing more than 15%. Now let us move on to the next, interstitial solid solution. Next one is interstitial solid solution. Here you see, my dear friend, there is no new crystal, there is no replacement of the host atom. Instead what happens, you see, suppose these are the iron atoms. So this position is known as interstitial void. Interstitial void, yeah, sometimes interstices. So if you add some impurity and that impurity atom is very small as comparison to the host atom, then that impurity atom may occupy this interstitial position. So this is solute atom, and these are solvent atoms. So such kind of solid solution is known as interstitial solid solution. Here you see only size is crucial to decide about the solubility. Size of the solute atom should be very small. It should be equal to or smaller than the interstitial void. So generally small atoms can only form such kind of solid solution. So these atoms are carbon, nitrogen, hydrogen and oxygen. The atoms which are less than angstrom range, they can follow the interstitial solution. They can form the interstitial solution. Also the size of this interstitial void is greater in FCC and HCP. If solvent has FCC or HCP, ये solvent के लिए मैं कह रहा हूँ, HCP structure, then the size of void is 0.41 R, where R is atomic radius of solvent atom, atomic radius of solvent atoms. But if it is BCC, solvent is BCC structure, then this size is 0.29 R. So it means in BCC solvents, interstitial void is smaller, so solubility of impurity atoms would be lesser. But in FCC structure, interstitial voids are larger, so solubility would be higher. So इसमें मैं dictate कर देता हूँ और आप लिख लीजिए. I am dictating, क्या मैं फर्जी लिखूँ? So मैं dictate कर रहा हूँ, please note down. सर केमिकल अफिनिटी फैक्टर क्या होता है? सर हम एक टेक्निकल में पढ़ा था ह्यूम-रोथरी रूल में. केमिकल अफिनिटी इज एबिलिटी टू अट्रैक्ट अनदर एटम्स इलेक्ट्रॉन टुवर्ड्स इटसेल्फ. किसी दूसरे एटम के इलेक्ट्रॉन को अपनी तरफ खींचने की क्षमता को आप सामान्य भाषा में याद रखो, इलेक्ट्रॉन के प्रति लालचीपन किसी एटम का उसकी केमिकल एफिनिटी कहलाता है. नहीं होनी चाहिए ज़्यादा सॉल्यूशन बनाने के लिए, क्योंकि अगर एफिनिटी ज़्यादा होगी तो वो इलेक्ट्रॉन को खींचने की कोशिश करेगा और इलेक्ट्रॉन छीनेगा अगर किसी से तो बॉन्ड बनाने की कोशिश करेगा. ईसु यादव. बेसिकली केमिकल एफिनिटी और इलेक्ट्रोनेगेटिविटी दोनों मोर आर लेस सेम चीज़ रिप्रेजेंट कर रहे होते हैं. सो इलेक्ट्रोनेगेटिविटी में हम आयनाइजेशन एनर्जी और इलेक्ट्रॉन एफिनिटी दोनों का एवरेज ले लेते हैं मैथमेटिकली, जबकि इलेक्ट्रॉन एफिनिटी में सिर्फ आयनाइजेशन एनर्जी को नहीं कंसीडर करते हैं, सिर्फ इलेक्ट्रॉन को अपनी तरफ खींचने की क्षमता को कंसीडर करते हैं. नॉट रिक्वायर्ड, यहाँ केमिस्ट्री नहीं पढ़ रहे हैं. लिखेंगे जरा. इन इंटरस्टिशियल सॉलिड सॉल्यूशन, इन इंटरस्टिशियल सॉलिड सॉल्यूशन, interstitial solid solution, the solute atom does not displace, the solute atom does not displace solvent atoms, does not displace solvent atoms. Solvent atoms. But the solute atom being very small in size, enters into a void, among the host atoms, full stop. Normally atoms which have atomic radius, normally atoms which have atomic radius less than 1 angstrom less than 1 angstrom are likely to form interstitial solid solution. Interstitial solid solution. Such atoms are carbon, nitrogen, hydrogen, oxygen. Carbon, nitrogen, hydrogen, oxygen. Next point. Interstitial solid solutions have usually very limited solubility, and they are formed preferably in solvents having HCP and FCC. Having HCP and FCC crystal structure. With interstices of a radius of a radius 0.41 r. r क्या है लिखा हुआ है 0.41 r. Full stop. In BCC lattice, the solubility is low. In BCC lattice, the solubility is low as the size of interstices in BCC lattice, the solubility is low as the size of interstices does not exceed 0.29 r. Does not exceed 0.29 r. 0.29 r. Good. Now I have क्या हुआ Before I proceed for the next discussion, let me announce tomorrow's schedule. Tomorrow class schedule, 8:30 a.m. to 12 noon. Subject is standard and quality control practices करके, standards and quality, that is, ठीक, standards and quality, this subject, ठीक, ये कल का आपका schedule है. Now I have to introduce few definitions. So let me introduce few definitions. मेरे साथ एक एक दो दो लाइन में लिखते चलेंगे आप. These definitions may be asked. So first definition is phase. So it can be defined as, a phase is defined as, a phase is defined as physically distinct, chemically distinct, chemically homogeneous and mechanically separable portion of a material system, A phase can be defined as physically distinct, chemically homogeneous and mechanically separable portion of a material system. Let us suppose we have a material at the room temperature in the solid phase. So when we increase the temperature, we are increasing temperature, it may convert into mixture of solid and liquid. So it is solid and liquid phase. Then it may go to fully liquid phase. It is liquid phase. Then it is liquid and gas phase. Liquid and gas phase. And then finally gas phase. So this is the meaning of phase. Although all the materials cannot have all these phases, but this is the maximum possibility a material system can have. This is when we increase the temperature, we keep on increasing the temperature. Yes, it is the last class of material science, Arun Vasisht. Please note down it quickly. Now, system. Every individual material is a system. Let us suppose water. So it is existing physically in the environment without any support, without being affected by the environment. So any material which has isolated existence in the environment, that is known as a system with respect to the material. So next heading is system. इसमें लिखेंगे the substances that are isolated and unaffected, the substances that are isolated and unaffected, by the substances that are isolated and unaffected by their surroundings, are called system, are called system. कोई सिस्टम आपका सॉलिड लिक्विड गैस किसी भी फेज में हो सकता है या उसका मिक्सचर भी हो सकता है. इट कैन बी सॉलिड लिक्विड गैस और इट कैन बी द मिक्सचर ऑफ सॉलिड लिक्विड गैस. नेक्स्ट, आफ्टर सिस्टम, नेक्स्ट definition is state. On a given condition of temperature and pressure, what is the physical condition of the material, whether it is solid, it is liquid, or it is gas, or it is in mixture, that is known as its state. So we can say that it is a physical condition of a system, it is physical condition of a system. It is physical condition of a system. The state of a system, the state of a system is given by its temperature and pressure, temperature, pressure, its temperature, pressure and mass, basically weight या composition. That is the meaning of state. Sir, this new subject standard quality can you give idea electronic students to take as if GS part will be ICT and material science is for us, so please guide. Nistha, I will say that you should attempt this standard and quality because it is a static portion. It is not general study. It is not related with current affairs. So the subjects which are static in nature, they are more scoring and they are more predictable. But the subjects which are related with current affairs, they are little bit difficult to absorb because you need to be aware with the news as well. So in my opinion, everyone should do this subject. State. After state, next definition is degrees of freedom. Degrees of freedom. Basically, these are the number of independent variables which are required to describe the state of a system. So there can be one variable, two variable or three variable, whatever be the. So degrees of freedom can be defined as number of independent variables required to describe the state of a system. Number of independent variables required to describe the state of a system, required to describe the state of a system. Then next आता है components. Component means how many elements are coming together to make an alloy. 2 elements, 3 elements, like that. So components. Number of elements used to make an alloy. Number of elements used to make an alloy. Number of elements used to make an alloy. Then phase equilibrium. Equilibrium means stable condition. And in the beginning I told you stability and energy are inversely proportional. So I am talking about equilibrium condition means system should have minimum energy. System की खुद की एनर्जी को फ्री एनर्जी कहते हैं. So it should have minimum free energy. So phase equilibrium. Phase equilibrium. This is the state of a system. This is the state of a system. This is the state of a system at any specified condition. At any specified condition when system possesses minimum free energy. When system possesses minimum free energy. Next one is phase diagram. It is actually the graphical representation. Diagram means graphical representation. So phase diagram, a graphical representation of the relationship, a graphical representation of the relationship between first temperature or pressure, temperature or pressure. Second, composition of material, composition of material, composition of material, and regions of phase stability, regions of phase stability under the condition of equilibrium, under the condition of equilibrium is called phase diagram, is called phase diagram. Under the condition of equilibrium is called phase diagram. ठीक है जी, क्विकली लिखें. Done? Let's talk about Gibbs phase rule. Gibbs phase rule. It says that P plus F is equal to C plus N. This is the Gibbs phase rule. P is number of phases present. F is degrees of freedom, degrees of freedom. C is number of components, and n is system variable. N value is already specified like this: n is equal to 1 if variable is temperature only. Variable is temperature only, such as in pure metal. But n is 2 if variables are temperature and pressure both, such as in alloys. So for metals and alloys, Gibbs Farage rule will differ. You please note down it. मेटल्स और एलॉयज के लिए गिब्स फेज रूल चेंज हो जाएगा. कैसे होगा देखते हैं. For metals, n is how much? 1. So P plus F is equal to C plus 1. This you can write F is equal to C minus P plus 1. F is degree of freedom. It cannot be negative. Cannot be negative. And cannot be in fractions. भाई ऐसा थोड़ा हो सकता है कि 0.1 या 1.7 या 1.2 वेरिएबल्स हो. वेरिएबल या तो 1 होगा, 2 होगा, 3 होगा, 4 होगा. इट कैन नॉट बी फ्रैक्शंस. ऐसा भी नहीं हो सकता है कि यू हैव -1 वेरिएबल, -2 वेरिएबल. सो इट कैन नॉट बी नेगेटिव. सो लोवेस्ट वैल्यू ऑफ डिग्री ऑफ फ्रीडम इज कि कुछ भी वेरिएबल ना हो. देयर शुड नॉट बी एनी वेरिएबल. ऐसे सिस्टम को कंस्ट्रेंट कहेंगे which cannot be varied, which has 0 degree of freedom. So we can say that कि degree of freedom यहाँ से f must be greater than or equal to 0. इससे छोटी वैल्यू नहीं संभव है. So you can write f is c minus p plus 1 greater than or equal to 0. So p is C plus 1. For pure metal, component is 1, then only it would be pure. So if it is pure metal, C value is 1. It means it can have at max 2 phases. So one phase is solid, other is liquid. And that is the reason in the beginning when I was teaching crystal structure, I told you keep perfect crystal structure is there, means pure material, then you will have sharp melting point. Means it can have only 2 phases, either solid or liquid. So it cannot have third phase. Third phase may be solid liquid mixture, but it cannot have solid liquid mixture. Below certain temperature it would be solid, and above that temperature it should be liquid. There is no other possibility for this case. So please note it down. This is for the pure metal. एलॉयज के लिए देखते हैं. फॉर एलॉयज, for alloy system variable is 2. So it will become P plus F is equal to C plus 2. P plus F is equal to C plus 2. So F is equal to C minus P plus 2, but F is greater than or equal to 0. So C minus P plus 2 is greater than or equal to 0. So from this, P is less than or equal to C plus 2. You cannot have more than C plus 2 components. Component plus 2, इससे ज़्यादा आपके पास नहीं हो सकता. So let us suppose you are making an alloy by using 2 elements. So it can have maximum 4 phases, right? So those can be solid, liquid, mixture of solid liquid, or some other kind of phases that we would be observing later on. So this is all about the Gibbs phase rule for metals and alloys as well. Please note it down quickly. How is the tea? बताइए कैसा टेस्ट है. देखो, wow, it's wonderful. On the basis of components, we can classify the phase diagram. So classification of phase diagram, classification of phase diagram on the basis of components. Phase diagram on the basis of components. पहला, C is equal to 1, pure material, unary phase diagram कहलाएगा. Unary phase diagram. C is equal to 2, then it is binary phase diagram. C is equal to 3, ternary phase diagram. Likewise आप बढ़ते चले जाएंगे, quaternary etc. We are studying basics of material science, so we are not going to be for complex system. And studying alloy, so need not to study about the pure, so इनको avoid करेंगे. We would be knowing few things about the binary phase diagram. Please note it down. Very sweet, sir. Tea and heart. Good. You guessed rightly. आधे लोग तो सो रहे हैं. अरे आखिरी क्लास है. माना कि मुझसे तुम बहुत नाराज हो, दुखी हो, गुस्से में हो, बट कुछ लिखते रहो. मेरी ज़रूरत लगेगी. आप देख रहे होगे अंतिम समय तक इवेंट टॉप करने के बाद भी आपको स्टारडम देने के लिए मैं ही काम आऊँगा. Done? हेडिंग दिखा दीजिए. सम पार्ट कट हो गया है. देखो जी जल्दी से सारा पार्ट. ये बढ़िया क्वेश्चन पूछा है. मातोंज ने पूछा है कि सर टी मेल है या फीमेल है. अच्छा, तुषार जी कह रहे हैं आप जैसे व्यक्तित्व को मटेरियल साइंस क्या जिंदगी का गुरु बना. अरे मटेरियल साइंस भी जिंदगी का ही पार्ट है. ये जीवन से अलग थोड़े है. मातोंज कह रहे हैं कि टी का जेंडर पता चल जाए तो उस हिसाब से इसकी प्रशंसा करें। टी इज अ न्यूट्रल जेंडर, ठीक। सो यू कैन प्रेज अकॉर्डिंगली। इट इज नॉट ही, इट इज नॉट सी, इसीलिए मैं क्या नाम दे रहा हूं, इट, ठीक है। सो इट इज न्यूट्रल जेंडर। आजकल वो बच्चों को, मेरे बच्चे 6 साल के हैं, स्कूल जाने लगे हैं, तो ग्रामर पढ़ाने के चक्कर में थोड़ा थोड़ा मुझे भी याद आ रहा है। सोहनी ने अच्छा क्वेश्चन पूछा है कि जीएस में व्हिच वन इज स्टैटिक इन नेचर एंड व्हिच वन इज डायनामिक। सो इन जीएस देयर आर 10 टॉपिक्स. So out of those 10, one is maths, other is reasoning and aptitude. This is common from GATE syllabus. You cannot afford to skip it. Compulsory हर व्यक्ति को करना ही करना है। ये छोड़ दिए तो आप अपने पैर पर कुल्हाड़ी मार रहे हैं। इसके अलावा there are total 8 more topics. आउट ऑफ दीज 8 टॉपिक्स, करंट अफेयर्स से जो जुड़े हैं वो है आईसीटी, एनवायरमेंट और करंट अफेयर्स खुद में, करंट अफेयर्स अपने आप में। दीज 3 आर डायनामिक इन नेचर। हालांकि 100% नहीं, इनके कुछ क्वेश्चन स्टैटिक होते हैं और कुछ क्वेश्चन डायनामिक होते हैं। रिमेनिंग ऑल सब्जेक्ट्स आर स्टैटिक इन नेचर। मंजीत जी, टॉपर चौक में तो सारी बात हो ही चुकी है, दौड़ा दौड़ा करके देख लो, ठीक है, उनका सफ़र कैसा रहा। बट अभी पढ़ाई पे फोकस करो, ये सब तो यूट्यूब पे पढ़ा रहेगा, एग्ज़ाम के बाद देख लेना, ठीक है। बाकी बात करेंगे कुछ। आइए पहले पढ़ लेते हैं। बाइनरी फेज डायग्राम, बाइनरी फेज डायग्राम। We are wanting to discuss copper nickel alloy system, copper nickel alloy system, right. Here we are taking one small assumption. गुरदीप जी कह रहे हैं कि सर आपसे नाराज होकर कहाँ जाएंगे। क्या बात कर दी सर आपने। अरे मैंने ऐसे ही कहा, आप मुझसे क्यों नाराज होंगे। आई नो यू ऑल लव मी सो मच। हियर टेम्परेचर एंड कंपोजिशन आर वेरिएबल पैरामीटर्स एंड प्रेशर इज हेल्ड कांस्टेंट। हियर टेम्परेचर एंड कंपोजिशन आर वेरिएबल पैरामीटर्स। ये हमने एजम्पशन लिया है while drawing this diagram, and pressure is kept constant, and pressure is kept constant normally at 1 atmospheric pressure, normally at 1 atm. So let's try to draw. इतना लिख लो तो एक डायग्राम ड्रा करते हैं। This axis is temperature, this axis is composition, this axis is temperature. So basically we are increasing temperature like this, and it is composition. weight percent में. Here we have 100% nickel. So this x is nickel weight percent we are varying. इसका मतलब कॉपर इधर हो जाएगा. So किसी एक के लिए देख लेते हैं, उसके अपोजिट चलोगे तो दूसरा हो जाएगा. It is 100% copper. This point 100% copper, this point 100% nickel. In between, nickel percentage is increasing from left to right and copper percentage is increasing from right to left. ग्राफ कैसे बनाया जाता है? For different temperature, different composition, you would be observing the state of material and then you would be pointing it out. लैब में एक्सपेरिमेंट करेंगे फिर उसको ड्रॉ कर देंगे. मैं डायरेक्टली ड्रॉ कर रहा हूं. आइए, have a look. So it looks like this. This line is denoting pure copper. So the melting point of copper is 1085 degrees centigrade. Melting point of copper is 1085 degrees centigrade. Pure copper. This line is denoting. So below this, copper is in solid phase. Solid means alpha. It is just notation. Room temperature पर जो भी phase होती है उसे alpha phase कहते हैं. Solid में. Then above this temperature it is liquid. So this is liquid phase. This is nickel. This line is representing nickel. The melting temperature of nickel is 1453 degrees centigrade. 1453 degrees centigrade. Below this temperature nickel is solid and above this temperature nickel is liquid. Between this range, this line is pure copper, this line is pure nickel. Apart from these two extreme ends, anywhere you will have certain percentage of copper and certain percentage of nickel, means it is an alloy. So alloy does not melt at a single temperature. In fact, alloy melts over the range of temperature. इसीलिए मैंने कहा था कि जैसे जैसे पीरियोडिक स्ट्रक्चर डिस्टर्ब होगा, मटेरियल विल मेल्ट ओवर द रेंज ऑफ टेम्परेचर. एंड इफ इट इज प्योर मटेरियल, इट विल हैव सिंगल मेल्टिंग टेम्परेचर. सो इट मेल्ट्स ओवर दिस रेंज ऑफ टेम्परेचर. सो इन दिस रेंज you have both phases alpha plus L, right? So basically this region, this alpha plus L, it is two phase region. This is two phase region. This one two phase region. Whereas this solid is single phase region and this liquid is single phase region. The line which separates two phase region with the solid state, that is known as solidus line. It is known as solidus line. The line which separates liquid phase with two phase region, that is known as liquidus line. First you please draw these things, then I have to discuss few point. So मैं इस डायग्राम को मॉडिफाई करूंगा, लेकिन पहले इतना आप लिख लीजिए. आलोक जी लिख रहे हैं कि सर अपना आशीर्वाद बनाए रखिए, आपके आदर्शों को हम अपने जीवन में उतार करके. सर जी थैंक यू वेरी मच फॉर मोल्डिंग अस इन द राइट डायरेक्शन. वी रियली गॉट द रियल फील ऑफ सब्जेक्ट. ऑल थैंक्स टू मेडी जी. जरिए ही आप हमें. थैंक यू बेटा, थैंक यू फॉर योर वंडरफुल वर्ड्स. अच्छा पहले ये बना लो, स्टेटमेंट दिखा देंगे. अभिषेक, first you draw this, then I will be showing the statement. Quickly please draw it. डू इट क्विकली, बनाइए इसे। डन, गुड। स्टेटमेंट लिख लीजिए। ये स्टेटमेंट कुछ लोगों का छूट गया था। अब एक चीज देखिए, लेट अस सपोज, इसको मैं हटा रहा हूं नाउ, इसी ग्राफ में कुछ मॉडिफाई करेंगे। Suppose we are in the single phase region at any temperature. Let us suppose it is some percentage of C naught. C naught is basically total weight percent of nickel. C naught is total weight percent of nickel, या fraction में लिख लीजिए, weight percent of nickel. Let us suppose 10%. So if we are at a temperature which is in single phase region, all these are different temperatures. So if our temperature is lying in single phase region and suppose C naught is 10%, then we can say that 10% nickel is in solid and 90% copper is in solid. So from graph directly we can comment how much solid is nickel and how much solid is copper. Let us suppose we are in the liquid state, our temperature is in single phase region, that is in the liquid state. Then again we can say that 10% of the liquid is nickel and 10% of 90% of the liquid is copper. Suppose the value of C naught is 10. But if our temperature is between these two extreme points, means our temperature lies in the two phase region, then out of this 10%, some of the nickel is in solid and some of the nickel is in liquid. And similarly, out of the 90% copper, some of the copper is in solid and some of the copper is in liquid. Suppose in the two phase region at any temperature, you want to know how much percentage of nickel is in solid and how much percentage of nickel is in liquid, then you cannot say it directly. So you have to use a concept that is known as concept of lever rule and tie line. So first of all try to understand tie line. जिस भी टेम्परेचर पर आपको कैलकुलेट करना हो, लेट अस सपोज एट दिस टेम्परेचर आई एम वांटिंग टू कैलकुलेट कि हाउ मच परसेंटेज ऑफ निकल इज इन सॉलिड एंड हाउ मच परसेंटेज ऑफ निकल इज इन लिक्विड. So starting from the binary region या two phase region, draw a horizontal line and ending at the two phase region. It should be strictly drawn in a two phase region. So this line is representing a constant temperature, let us suppose 1200 degree centigrade. So this line is known as isotherm या tie line. It is known as tie line or isotherm. So there would be family of line. हर एक टेम्परेचर के लिए टू फेज रीजन में you would be drawing horizontal line and these lines are known as tie line. This tie line will have some interception here. ग्राफ पर इसे रीड कर लीजिए. जो लिक्विडस लाइन के साथ हो रहा है, इसे नाम दे देते हैं Cl, and it will have some intersection with the solidus line, so इसे नाम दे देते हैं C alpha. So now C naught is total weight percent, C alpha is intersection, basically you can say that at this temperature fraction of nickel in solid, and at this temperature fraction of nickel in liquid. So C naught and C alpha कोई कह रहा है 1455 दिया है गूगल में, भाड़ में जाए गूगल, जो मैं लिखा रहा हूँ वो लिखो, वैसे भी 1-2 डिग्री कोई फर्क नहीं पड़ता है, एग्जैक्टली नहीं पता चल पाता. So C alpha is weight percent of nickel in solid, and Cl is weight percent of nickel in liquid. Basically weight percent की बजाय fractions में ले लेंगे, ठीक. Now suppose I want to calculate W alpha, that is fraction या weight percent कुछ भी, fraction of nickel in solid in two-phase region, and WL is fraction of nickel in liquid in two-phase region. So let's see what is W alpha. W alpha is given as C naught minus Cl, C naught minus Cl, C alpha minus Cl, and WL is given as C alpha minus C naught upon C alpha minus Cl. These two expressions are known as Lever rule. These two expressions are known as Lever rule. इनको लिखने से पहले एक लाइन मैं डिक्टेट कर रहा हूं, पहले उसे लिखें, उसके बाद इन्हें लिखें. Write down. If the temperature and, first you note down a line, then you would be writing this. If temperature and composition position is located, if temperature and composition position is located within two-phase region, then tie line and lever rule is used to calculate fraction of nickel in solid and liquid in two-phase region. Full stop. Next point. Next point. In two-phase region, a series of in two-phase region, a series of horizontal lines, are drawn comma लगाएं, one at every temperature, one at every temperature. One at every temperature. Each of these lines is known as tie line. Each of these is known as a tie line or isotherm, निष्ठा बेटा सी अल्फा आप देखें तो उस टेम्परेचर पर सॉलिड में निकिल का क्या परसेंटेज है, ग्राफ से वो रीड करना पड़ेगा आपको, ठीक। और सी एल देखें तो उस टेम्परेचर पर जिस पर हम कैलकुलेट कर रहे हैं लिक्विड में निकिल का क्या परसेंटेज है, दैट यू हैव टू रीड फ्रॉम द ग्राफ, ठीक। एंड टोटल परसेंटेज जिस पे हम कंपोजिशन कैलकुलेट करना चाहते हैं वो सी नॉट है। प्लीज ड्रॉ कर लें और इस बात को लिख लें। Please draw it and write it. Done? अच्छा मुझे लिखने में गलती हो गई है क्या, सॉरी, ये लिक्विड होना चाहिए, दिस शुड बी लिक्विड। बन गया, प्लीज नोट इट डाउन। Done? Good. Now please have a look. Again come to this graph. Let us suppose if it is a pure metal, suppose it is copper. So when the phase is changing here, So below this temperature 100% copper in solid and above this temperature 100% copper in liquid. So there is no compositional alteration, composition में कोई change नहीं हुआ. इसी तरह से यहाँ भी अगर phase change हो रही है but 100% nickel and 100% nickel in solid, 100% nickel in liquid. There is no compositional change. Such kind of phase transformation where during the phase transformation there is no alteration in composition, they are known as congruent phase transformation. But if you see here, any phase change will take place. Let us suppose it was 10% nickel and 90% copper in solid. As soon as the phase is changing and you go to the binary phase region, out of this 10%, some of the nickel is in solid and some of the nickel is in liquid. So percentage composition has changed during the phase composition. Now whole 10% is not in solid. Out of this 10%, some is in solid and some is in liquid. So compositional alteration has took place. Such phase transformations where compositional alteration took place, they are known as incongruent phase transformation. So define कर लेते हैं. Congruent phase transformation. Congruent phase transformations. Those phase transformations those phase transformations for which there are no compositional alterations, for which there are no compositional alterations, are known as congruent phase transformations. Congruent phase transformations. इसका एग्जाम्पल है मेल्टिंग ऑफ अ प्योर मेटल. मेल्टिंग ऑफ अ प्योर metal. There is no compositional alteration, but phase will change. Whereas incongruent phase transformation, incongruent phase transformations during the phase transformation at least one of the phases will have compositional alteration. कम से कम कोई एक phase का composition तो जरूर change होगा. For incongruent phase transformation, incongruent phase transformation at least one of the phases will experience a change in composition. Example है melting of an alloy. melting out of an alloy. So this is the definition of congruent and incongruent phase transfer. Please write down it quickly. Done? Done. Good. So this was the thing which I wanted to teach you in alloys and phase diagram. इसके बाद आता है iron based alloys and non ferrous alloys that you have to study from the book. There is one more topic, composites. In last 6 years we do not have get any question from composite in GS. Although you get question in mechanical material science paper 2, you get question in EC and electrical material science paper 2, but don't get questions in GS. So I am very apprehensive whether it is in the syllabus or not. So this year in almost all the batches I tried to drop this topic. नेक्स्ट ईयर अगर इस साल भी क्वेश्चन नहीं आया तो इसे मैं छोड़ दूंगा, नेक्स्ट ईयर से सिलेबस से ही हटवा दूंगा. इन पेपर वन सिलेबस इज नॉट मेंशन्ड एक्चुअली बाय यूपीएससी, सो आई कीप ऑन गेसिंग अकॉर्डिंग टू द पेपर. अब 6 साल से किसी टॉपिक में क्वेश्चन नहीं आया, सो आई कैन गेस कि शायद ये पार्ट ऑफ द सिलेबस नहीं है या दे आर नॉट इंटरेस्टेड टू आस्क. अगर पूछ लेंगे तो फिर पढ़ना पड़ेगा. ठीक. सो फॉर दिस व्हाट आई विल डू, एक 30-35 मिनट का वीडियो है एंड दैट आई विल बी गिविंग यू. 30-35 मिनट या 40 मिनट, नॉट मोर देन 1 आवर एक वीडियो दे दूंगा. आई विल नॉट एडवाइज यू टू वेस्ट योर टाइम ऑन वॉचिंग दिस सो मच, लेकिन अगर समय हो तो 10-10 मिनट करके देख लीजिएगा कि अगर गलती से पूछ लिया गया सो यू कैन बी कंफर्टेबल टू आंसर द क्वेश्चन. सो मेरी तरफ से मटेरियल साइंस में आपके लिए बस इतना ही था और कुछ भी नहीं. बेसिक्स ऑफ मटेरियल साइंस में जीएस सिलेबस में it is very vast syllabus. It's not possible to cover each and everything. It's not like the technical subjects where we cover each and every minute points. जिन्होंने मुझसे पढ़ा होगा टेक्निकल सब्जेक्ट, चाहे ईडीसी पढ़ा होगा, डिजिटल पढ़ा होगा, एनालॉग पढ़ा होगा, कुछ भी पढ़ा होगा, so there you may have seen that कि I try to cover each and everything because the sufficient time is available and things are predicted from the examination bodies also. But here time is limited, syllabus is undefined, so it's not practically possible to teach each and everything. So keep on studying. I tried to make certain basic fundamentals, try to give you certain basic fundamentals. You keep on building your concept on these fundamentals. इन्हीं fundamentals पर अपने concept build करने की कोशिश करते रहिए. खूब क्वेश्चन करिए, प्रीवियस ईयर क्वेश्चन करिए, थ्योरी बुक पढ़िए, द थ्योरी बुक विच हैज़ बीन गिवन टू यू, उसको पढ़िए एंड ट्राई टू रीड, ट्राई टू डू टेस्ट सीरीज क्वेश्चन, उसको करिए खूब, ताकि आपका वाइडर डोमेन कवर अप हो सके, राइट। एंड फॉर GS I will suggest that कि टारगेट अराउंड 80 to 100 मार्क्स, उसके अकॉर्डिंग आप अपनी प्लानिंग करिए। 80 मार्क्स आर कंसीडर टू बी गुड इन दिस पेपर, उससे ज़्यादा थोड़ा सा बहुत मुश्किल होता है। 100+ इज़ वेरी डिफिकल्ट, यू डोंट हैव दैट मच टाइम टू स्टडी सो मेनी थिंग्स। सो अकॉर्डिंग टू द 80 मार्क्स यू हैव टू फोकस कि कैसे आप कर पाओगे, ठीक। और कुछ मैं सप्लीमेंट्रीज प्रोवाइड करता रहूँगा, जैसे देयर वुड बी अ लेक्चर 4-5 days before the examination, so I will try to summarize the subject in that lecture। YouTube पर लाइव होगा 3-4 घंटे का, उसको देखिएगा, that will help you at the last moment to revise the concepts। और रही बात एग्जामिनेशन में, आप देखें 50% किसी भी ब्रांच में नहीं चाहिए। जो हाईएस्ट प्रीलिम्स की कट ऑफ है दैट इज रफली अराउंड 230-236 मार्क्स, कुछ ऐसे है सिविल इंजीनियरिंग में। ईसी में तो बहुत कम है, 184 के आसपास है। यानी इफ समवन इज टारगेटिंग फॉर 250+, he will definitely get selected, and 250+ means 50% of the marks। So for 50% you have already studied, try to revise it as many times so that in the pressure situation you can deal with the question। So again and again practice question, appear in the test series, figure out your shortcomings, identify your weaknesses, overcome those weaknesses। So करते रहिए करते रहिए करते रहिए, and finally you will get succeed। ये one day process नहीं है कि आज रात में सोए और सुबह उठ के IAS बन गए, it's not like that। You need a consistent effort। आप कई बच्चे देखेंगे, कई सारे टॉपर स्टॉक में देखेंगे कि देर आर स्टूडेंट्स हु मिस्ड बाय 1 marks 2 marks इन द लास्ट अटेम्प्ट, बट दिस ईयर दे आर अमंग द टॉपर्स, टॉप 5 टॉप 3 में रैंक लेकर के आए हैं। सो इवन इफ यू मिस इट, सो द मार्जिन शुड बी नैरो सो दैट नेक्स्ट ईयर यू कैन टॉप इट। But if the margin is very high, that would be demotivating। So put your 100% effort। Manjeet is saying that, can you please tell subject wise weightage of GS? Not possible to tell subject wise weightage because UPSC is varying every year। किसी साल किसी सब्जेक्ट को बहुत ज़्यादा कर देते हैं, किसी साल किसी सब्जेक्ट को बहुत कम कर देते हैं। सो दैट वुड बी एन idiotic strategy to study the subject wise weightage। They have said that कि minimum weightage of any subject will be 5% and maximum weightage would be 15%। So the weightage of the subject should be varying between this 5 to 15% in all the subjects of general studies। So I am helpless in this front। I cannot categorize कि ये subject important है, ये नहीं important है। Every subject is important। For you I will suggest that कि according to your convenience try to study कि आप किस subject में comfortable हैं। ऐसे कम से कम 6 से 7 सब्जेक्ट तो जरूर तैयार करिए, 6 to 7 सब्जेक्ट से यू मस्ट प्रिपेयर, जिसमें मैथ और एप्टीट्यूड बिल्कुल भी इग्नोर मत करिएगा बिकॉज दे आर वेरी इंपॉर्टेंट सब्जेक्ट एंड दे आर द सब्जेक्ट्स व्हिच आर मोर डूएबल, right? Sir, please share your Telegram ID for doubt। I have shared in the beginning। So at Telegram I have made a group and that is basically @Anunaad ANUAAD 22, राइट। या आप ऐसे भी सर्च कर सकते हैं अनुनाद ANUAAD। लेट्स बी इन रेजोनेंस, लेट्स be in resonance। In this group students keep on asking questions, you can also ask your queries। मोस्ट ऑफ द टाइम स्टूडेंट्स एक दूसरे को आपस में ही रिप्लाई कर देते हैं। अगर कोई नहीं कर पाता है तो वहाँ पर मैं भी रिप्लाई करता हूँ। सो थैंक यू वेरी मच फॉर योर प्रेजेंस। ईसी और इलेक्ट्रिकल के स्टूडेंट अभी बने रहें, 1 बजे से हम लोग दोबारा आपकी क्लास स्टार्ट करेंगे। फ्रॉम 1 PM ऑनवर्ड्स आई विल बी स्टार्टिंग द लेफ्ट ओवर पोर्शन फॉर पेपर 2। सो पेपर 2 के लिए ईसी और इलेक्ट्रिकल का जो सिलेबस बचा हुआ है उसकी क्लास स्टार्ट होगी। दैट विल स्टार्ट फ्रॉम 1 PM। तब तक मैं भी कुछ थोड़ा सा नाश्ता पानी कुछ कर लेता हूँ, थोड़ा सा एनर्जी ले लेते हैं, आप भी कुछ खा पी लीजिए। मिलते हैं 1 बजे। बाकी की ब्रांचेस के लिए विश यू गुड लक फॉर योर एग्जामिनेशन। कीप ऑन प्रिपेयरिंग। जो भी आगे के 30-40 दिन 45 दिन बचे हुए हैं, इसको पूरी एनर्जी और पूरी इंटेंसिटी के साथ प्रिपरेशन करिए, ठीक है। देखिए, युद्ध होने से पहले जो हार मान लेते हैं वो योद्धा नहीं कहलाते हैं। सो एग्जाम से पहले नहीं गिव अप करना है, वेदर द प्रिपरेशन इज गुड और बैड। एग्जाम के बाद डिसाइड करना है कि अगले साल क्या करना है नहीं करना है, बट टिल एग्जामिनेशन यू हैव टू गिव योर बेस्ट। सो अपना अच्छा करने की कोशिश करिए, और आप अगर अपना अच्छा करेंगे तो आपके जीवन में कुछ ना कुछ अच्छा होगा। कीप थिंकिंग इन द पॉजिटिव मैनर। तुलसीदास जी ने कहा है कि जाकी रही भावना जैसी, प्रभु मूरत ने देखी तैसी। द वे यू थिंक द सेम वे थिंग्स आर प्रेजेंटेड बिफोर यू। सो थिंग्स आर हैपनिंग इन योर लाइफ ट्वाइस। दे आर मैनिफेस्टेड फर्स्ट इन योर माइंड एंड देन they are coming into the reality. So if your thoughts which are coming in your mind, they are pure, then the things in your life would be positive. But if your thoughts are negative, then obviously in your life negative things will happen. So consider this very important concept of life, to get any kind of success in your life, your thinking process must be positive. So start thinking in the positive direction. Thank you very much. मिलते हैं 1 बजे ईसी और इलेक्ट्रिकल से। बाकी के ब्रांचेस के लिए अलविदा। कल का शेड्यूल आपका बता दिया है, 8:30 ऑनवर्ड से यू हैव शेड्यूल फॉर द क्वालिटी स्टैंडर्ड्स ऑफ क्वालिटी एंड कंट्रोल, राइट। थैंक यू वेरी मच, हैव अ वंडरफुल टाइम। Thanks everyone, thank you everyone, thank you. Your messages are reaching to me, I'm reading that. Thanks each and everyone.